Welcome to Pure Physics. Today we're going to see an important topic called as dimensional analysis method of class 11th. This topic is the most common to all the syllabus and boards, and in most of the competitive exam the questions under this topic will be asked in the first part of the questions in the physics paper, and most of them will be problem related or numerical problem related. Less questions will be asked from theory, but certain questions will be like straightforward questions. Certain questions you need to convert the answers. So before moving on to the numerical problem, let us understand the basic concepts of dimension analysis method. So first we have physics. Under physics we have a branch called as mechanics, and under mechanics we have physical quantities. I wrote physical quantity, but here I'm going to write physical quantities because there are a number of physical quantities in mechanics that comes under physics branch. So now I need to convert this physical quantities into their base quantities, independent base quantities, independent base quantities. So I need to convert these physical quantities into independent base quantities. What are these independent base quantities? There are three independent base quantities, which are M, L, T. M represents the dimension for mass, L represents for the dimensions for quantities relating to length, and T represents for time. Now, whatever physical quantities I have, I need it to convert it into independent base quantities, where it will be represented using three independent base quantities, which is M, L, T, and these M, L, T's will have exponents x, y, z. The x, y, z are the exponents of the base quantity, and this x, y, z will differ for each physical quantity. It will not be the same for all the physical quantities. So for one quantity the powers will be one thing, and for other physical quantities it will be different from the first one. So now when you convert the physical quantities in terms of their independent base quantities, and where the independent quantities will have their exponent or powers which represents the dimensions of the physical quantity. So x, y, z are the powers. These powers represents the dimension of physical quantity. So these represents the dimensions of physical quantities. So first, from again, under physics we have a branch called as mechanics, and under mechanics we deal with physical quantities, and we convert the physical quantities into their independent base quantities, where there are three independent base quantities, that is M, L, T, in which they have their own powers x, y, z, and these x, y, z's are called as powers, and their powers are nothing but the dimensions of the physical quantity. So now we can define the statement of dimension of a physical quantity by the statement like, dimension of a physical quantity can be defined as any physical quantity that can be expressed in terms of independent base quantities whose power represents the dimension of the physical quantity. I repeat, the dimension of a physical quantity, So always when you write the dimension, you need to enclose it with square bracket. So whenever you write MLT, whenever you convert a physical quantity into MLT, you need to enclose it in square brackets. Otherwise, there is a chance where you will reduce your marks. So you need to enclose MLT in within a square brackets. So the dimension of a physical quantity can be defined as any physical quantity that is expressed in terms of independent base quantity, whose powers represents the dimension of the physical quantity. So this is what the definition of dimensional of a physical quantity is. Now we will move on to another concept. It's an important concept. where we have four types. One is related to variables. One is related to variables, and the other is related to constants. Constants. One is related to variables and the other one is related to constants. So there are two types of variables. One is dimensional variable and dimensionless variable. And there are two types under constants, that is dimensional constant and dimensionless constants. So first we will see what is dimensional variable. What is dimensional variables and dimensionless variables. So here in dimensional variables, the physical quantity will contain the dimension as well as variable values. So the physical quantity that contains dimension as well as variable values are called as dimensional variable. Example, I can give you length, mass, etc. So these are dimensional variable. Dimensionless variables are physical quantities that does not contain dimension. It is dimensionless variables are physical quantities that does not contain dimension but does contain variable values. So these are what example I can give as refractive index. Refractive index. So what is the unit of Snell's law? Snell's law is what? In 10th you would have learnt about Snell's law, which is sin I by sin R. So this is a dimensionless quantity, dimensionless variable. Here there is no unit because the units will get cancelled. Or you can say about what we can say. So for now we will give refractive index and etc. Now for moving on to constants, we have two types. One is for dimensional constant and dimensionless constant. So we have two types, and which is dimensional constants dimensional constants and dimensionless constants. So what are these? So dimensional constants are physical quantity which contain constants as well as it contains dimension, same as the definition of dimensional variable. So dimensional constants are physical quantities which contains dimension as well as constant values are called as dimensional constant. Example we can give as gravitational constant and Planck's constant. So this Planck's constant is the most repeated in all competitive exam. We will see the conversion of Planck's constant into dimensional quantity. We will see that in next video, where we will see about problems. So then dimensionless constants. Dimensionless constants are physical quantity which does not contain dimension, but they do contain, but they do have constant values. For example, Euler's number, Euler's number, or any number, or any number. What is this any number? If they ask you to find the dimension of 2, if they ask you to find the dimension of 2, what is the answer? You cannot express because you don't have any unit for this value 2. So your dimensional base quantities will become MLT. The powers will become 0, 0, which is equal to dimensionless constant, which is equal to dimensionless constant. You will write dimensionless constant here. So these numbers and Euler's number and this pi value all are dimensionless constant. Dimensional constants are gravitational constant, Planck's constant. And again, dimensionless variables, I have refractive index. And as I recall, there is another example for dimensional variables, which is strain. Strain. We have strain as an example for dimensionless variables. And what is strain? We will learn this in chapter number 7, properties of matter. So now I will say what is strain. Strain is nothing but change in length by original length, because change in length by original length. Here the unit of change in length is also meter, and the unit of original length is also meter. So when you divide meter by meter, you get 1. So the unit cancels and there is no unit left. Therefore, there is no dimension. If you have unit, you can write the dimension. Here length mass contains their unit, therefore we have dimension as well as variable values. So therefore these are the two different variables and these are the two different constants.